On July 21st, the Hubble telescope treated us to a new image of the third interstellar object to ever be seen. Passing through our solar system, the picture shows the speeding visitor named 3I's ATLAS in unprecedented detail, and scientists are eager to analyze the data it beamed back to Earth. Here's what we know so far. Let's start with the image itself. The Hubble telescope and its wide-field camera 3 got an incredible view of the comet named 3I Atlas, which came from beyond our solar system on July 21st when the object was 277 million miles, 445 million kilometers from Earth. In the image, a teardrop-shaped dust cocoon can be seen streaking from the comet's icy nucleus. A comet's nucleus is its solid core, made of ice, dust, and rocks. When comets travel near stars such as the Sun, heat causes them to release gas and dust, which creates their signature tails. For this comet, though, that shape is only one piece of evidence suggesting it's not from around here. And while scientists wait for even more data to come in from all over the world, they're combing through existing observation sets to learn as much as they can about the comet. One team of researchers has honed in on the shape of the comet's dust plume to estimate its size. The results were published in a new paper accepted by the astrophysical journal Letters. According to their findings, the small nucleus, which cannot be directly seen, could be as large as 3.5 miles, 5.6 kilometers in diameter, or as small as 1,000 feet, 305 meters across. That size range might seem huge, but the lead study author says it's typical for cometary nuclei. David Jewett is a professor of astronomy at the University of California, Los Angeles, and the paper's lead author. He told Live Science that measuring the size of a comet's nucleus is tricky, because most of the time they appear as points of light rather than actual physical objects. That's the case for 3I ATLAS too. So scientists measure the rate at which the dust plume expands outward and compare that with models of how well mixed the dust is within the coma, the cloud of gas and dust surrounding the comet's nucleus. From there, they can determine the size of the nucleus, but only within a certain range. Jewett says there's an upper limit based on how fast the coma is expanding, and a lower limit based on how well mixed the dust is. That said, new observations, like those made with Hubble, are shedding more light on the comet's size. Meanwhile, other space-based telescopes, like the James Webb Space Telescope, the Transiting Exoplanet Survey Satellite, and the Neil Gehrels Swift Observatory, along with ground-based observations from the W.M. Keck Observatory in Hawaii, could reveal more about the object's chemical composition. The comet is expected to remain visible to ground-based telescopes through September before passing too close to the Sun to be spotted, until it reappears on the other side of our star in early December. But big questions about 3I Atlas remain, some of which may be impossible to answer, including where exactly it came from. No one knows where the comet came from. It's like glimpsing a rifle bullet for 1,000th of a second. You can project that back with any accuracy to figure out where it started on its path, said lead study author David Jewett, professor of astronomy at the University of California, Los Angeles, in a statement. While the comet appears to behave like those that originated in our solar system, as evidenced by that dust plume Hubble captured, the speed of 3I Atlas is one indicator that it's a visitor from another solar system in our galaxy. Scientists estimate it has been traveling through interstellar space for billions of years. As objects travel through space, they experience a gravitational slingshot effect from whizzing by stars and stellar nurseries. That increases their momentum. So the longer 3I Atlas has spent in space, the faster it moves. And at 130,000 miles per hour, this comet definitely qualifies as speedy. The comet is only the third known interstellar object to have been observed in our solar system, after Oumuamua in 2017 and 2I Borisov in 2019. Oumuamua is still the only interstellar object to have been observed passing through our solar system without having a tail, leading some scientists to hypothesize that it could be humanity's first alien megastructure. Others have suggested it could be a hunk of nitrogen ice that broke off of a frigid Pluto-like exoplanet. And 2I Borisov looked like your classic comet with a fuzzy halo round its nucleus, and long tails of dust and gas streaming behind it. Of the two previously observed interstellar objects, only 2I, Borisov had a speed that gave scientists clues about its origin. 2I, Borisov seemed to be coming from a solar system that was rich in heavy elements, possibly because it passed through a stellar nursery where stars exploded and dispersed heavy elements like iron, silicon, and oxygen before being ejected into space. But 3I, Atlas doesn't have a simple explanation. It seems unlikely that it originates from the same places as the previous interstellar comets, because if they did, we would expect it to be moving slower. It could be that it came from a completely different part of the galaxy, said Matthew Hopkins, a recent doctoral student in the Department of Physics at the University of Oxford, who authored a separate study about the comet. For Hopkins, the discovery of 3I's ATLAS was incredibly fortuitous. The find occurred just 5 days after he finished his doctoral work, which involved a lot of time spent making predictions about future interstellar object discoveries. In a few months, he'll begin a postdoctoral research fellowship at the University of Canterbury in New Zealand, where he'll continue to research 3I's ATLAS. During his doctoral studies, Hopkins and his collaborators in New Zealand developed the Tautahi-Oxford model, a combination of data from the Milky Way, star population, and models of how planetary systems form that could help astronomers determine what interstellar object populations should look like. Now, Hopkins is the lead author of a separate preprint study about 3I's ATLAS. One thing his team is doing is comparing the latest observations of the comet to their model to see how well predictions stack up against reality. They also hope to use the comet as a testing ground for their model. If our model is correct, and this is a long-period comet that has been in the Oort cloud of our solar system for a very long time, then it should display certain characteristics, Hopkins wrote in an email. We can use the fact that it is an interstellar object to test our model of how planetary systems form. Hopkins says it has pure chance that the interstellar comet crossed into our solar system, but it is not entirely rare. We just don't see these visitors most of the time. Interstellar objects pass through the solar system all the time, especially the smaller ones, which are more numerous, 80 the size of Oumuamua, about 656 feet or 200 meters across, pass through the orbit of Jupiter every year. They're just too small to detect unless they get very close to the Earth, Hopkins wrote in an email. So how do you spot an interstellar object? There are surveys that scan the night sky looking for objects that move, but they usually focus on smaller objects. It is not always easy to tell if an object really is hurtling through space or just looks like it is. That is because a lot of things can make it appear as though an object is moving across the sky. Satellite launches, airplanes, meteors, stars with high proper motions, and stars that are nearby but at a much greater distance than an interstellar object. However, astronomers are eager to have the Vera C. Rubin Observatory, which released its first images this summer, scanning the skies for interstellar objects. During its 10-year survey, the observatory will take pictures of nearly the entire visible sky every few nights. With the telescope's massive primary mirror spanning 28 feet 8.4 meters across, it can spot small, faint and distant objects, and it's scanning the entire sky every 3 nights, allowing the telescope to better catch sight of rapidly moving interstellar objects. This latest interstellar tourist is one of a previously undetected population of objects bursting onto the scene that will gradually emerge, Jewett said. This is now possible because we have powerful sky survey capabilities that we didn't have before. We've crossed a threshold, Hopkins agrees. Over the next decade or so, we should see more interstellar comets and other kinds of interstellar objects. This will teach us more about the environment around other stars and how planetary systems form. It will also allow us to test models like the Tautahi-Oxford model, which could help us learn more about where 3I, Atlas came from. It's super exciting. We're on the cusp of something, Hopkins said. In the meantime, astronomers around the world will keep their eyes on the skies, watching and waiting for the next interstellar object to pass through our solar system. Thanks for watching.